Hi, my name is Yann Briand. I'm a climate policy researcher at the Institute for Sustainable Development and International Relations, affiliated to Sciences Po Paris in France. I will present today the deep decarbonization pathways for freight in large and fast-growing economies. This presentation has been done within the project called the Deep Decarbonization Pathways in Brazil, India, Indonesia, and South Africa. And here you can find the different partners in these different countries: the Federal University of Rio de Janeiro, the Institute of Management of Ahmedabad, the University of Cape Town, and the Institute of Technology of Bandung. This work is supported by the German government and the International Climate Initiative and the 2050 Pathways Platform. Just in one word, the Deep Decarbonization Pathways Initiative has been launched prior to COP21 to demonstrate the interest of nationally based proposals and the role of long-term trajectories to inform short-term policies. This represented at this time a network of 16 independent country research teams, and now it represents more than 36 different research teams in 36 different countries all over the world, as you can see on the right side on the map that you can find back on the website ddpinitiative.org. This research network share a same objective, which is to design transparent long-term pathways supporting the decarbonization of economies compatible with the objective to reach the global carbon neutrality around mid-century. The DDP research network shares also a common approach and a common understanding of the challenges to build consistent and policy-relevant pathways. Here are 5 main items that explains what we are doing and why we are doing it. So first, we do bottom-up and country-led analysis because we think it's required to build country-relevant pathways. We worked on a multi-scenario approach to define from the key global and country-specific uncertainties, because we think this is the good way to inform on possible futures and consequences of the different actions. Third, we work on an iterative and backcasting approach, and we think this is required to identify the compatible short-term actions and consider some systemic changes with profound inertia to reach the mid-century development objectives and emission targets. Fourth, we define consistent and detailed sectoral pathways, and we think that to do that, this requires a systemic description describing all underlying drivers with qualitative and quantitative sectoral details with consistent demand-side and supply-side articulations going far beyond the usual quantitative energy and emission trajectories that you can see in most of the energy and climate scenarios that exist. Fifth items is we want to build actionable and policy-relevant pathways, and this requires to be transparent and comprehensive by stakeholders. We do believe that the current models alone do not enable to structure this policy discussion, and that we need a policy-relevant framework to compare qualitative and quantitative descriptions to structure and facilitate stakeholders' discussion, and a framework that is able to accommodate quantitative analysis coming from different sources. So to get more detail on the methodological approach, I will just refer to these 2 recent publications, one in Nature Climate Change last year and the other one in Climate Policy this year. So this is the analytical framework that we use to build our pathway. I will focus mainly on the modes of representation because I will then discuss these elements. So to explain you the function exactly. So the storyline and the dashboard. So the storyline structured a systemic description of the pathway around all categories of drivers, covering economic, demographic, technical, organizational, and behavioral dimensions that influence the emission trajectories and other development trajectories. It provides a literal and comprehensive representation of this underlying transformation, which concerns the future action of all the different stakeholders. On the other hand, the dashboard structures a synthetic and quantitative representation of the pathways each 10 years, from 2010 to 2050, showing its main components and effects through national selected national and sectoral selected indicators. It provides a quantitative only representation of the specific low carbon transformation, and its role is to try to support the policy discussion and to control some long-term objectives and transition effects. So here, with this graphic that I will not describe more, you can see this iterative process that we use to build the consistent pathway, and you can find more details in the latest publication I have quoted. These are the elements of the storyline and the dashboard that are related to the freight and that we have used to define the pathway. So we have 5 main chapters of the storyline. The economic and social macrostructure, describing the transformation of the system of production, consumption, and exchange of goods. The second one on the management and operations of infrastructure of transport and logistics. The third one on the logistics services and operations. The fourth one on technological development and supply of low carbon goods transport vehicles. And the fifth one on the production and distribution of low carbon fuels. We have built this analytical framework around these 5 families of drivers, because we found that most of the time the family 4 and 5 were the most developed in current scenarios, and that the first one, the the one second and third one, were less developed, even if they were really important for the deep decarbonization, for first the articulation with the technological development and technological solution, but also to try to implement some other drivers related to this aspect. On the other side, on the dashboard families, we have built a set of more than 50 indicators that are structured around these 5 main families. One describing the goods and mobility with a description with 1 million ton of goods, with 6 categories of goods, with 2 main distance categories. The modal structure that is showing the ton kilometer by 3 type of flows: transit, import-export, and national, and also the distance categories. Logistic indicators to compare road and rail, and they are related to cost, to time, to distance, and they are also provided the average load factor for road. And a zoom on road freight transport, providing indicators on the vehicle stock, sales, by different types of road vehicles, by 5 types of engine technologies, providing also the traffic for these different type of vehicles around the different distance categories. And finally, the fifth category is around the national energy consumptions and related emissions and main drivers of these emissions. Here, I will now start with the example coming from Brazil and India. And here you can find a summary of the main elements of the narrative for Brazil. I will not enter into all the details related to the Brazilian storyline, but just highlight some of them that could help to explain what we want to do with this storyline. And here you can find, I have highlighted some elements, so following the same structure I presented just before, and that highlight different values. So talking to different stakeholders. Here, for example, the first sentence is clearly for policymakers, to say policymakers can change their position and have an effect on the way they consider long-term investment, the access to international finance, and could have an effect on reducing the bureaucracy in rail and water activities, which could then have an effect on the share of rail and water-based solutions. Other elements are are related to the organization, like the urban consolidation center shame, or the different infrastructure investment. Other are purely regulatory elements, like the restrictions of the right of way between rail concessions that needs to be removed to facilitate rail access, and other elements that are economic, like the amortization rules or the tax reduction for inland waterways and cabotage to favor water-based transport. So I will not give you the full picture of the Brazilian scenario, but just to highlight the type of detail and elements that are provided and articulated to try to reduce and provide a comprehensive pathway of decarbonization pathway. Sorry. So this is the rest of the storyline for the Brazilian case, and for the Indian case, I will not do the same because the Professor Gupta has done a presentation just before within the same session. So if you have any question, please refer to her. And now I will finish on the cross-country comparison of India and Brazil on a key selected indicators. So first of all, on the overall CO2 emissions, the two scenarios that the teams have started to build provides a reduction about around half. I mean the emissions are cut by half between 2010 and 2050. What's interesting is that this means that they see that freight is quite difficult, and that freight will still have remaining emissions by 2050 and will not be fully decarbonized, which means then that this requires to be compensated or to be absorbed probably in the next years, because all countries needs to try to deeply reduce and have a neutral vision by mid-century, even for the developing countries around 2050 to 2070. Sorry. On the emission drivers, we can see here between India and Brazil that these are not the same. So first, we can clearly see that in the Indian case, the demand and the demand projection is quite high. So India is projecting that the demand in ton kilometers will increase by more than 4.5 times compared to 1.5 for the Brazilian scenario, which then have an effect, of course, on the action that is required on the other levers. So we see that the energy efficiency is actually reaching almost the same point, so a 50% reduction. So in both countries, the red line. But of course, the action on the carbon intensity needs, therefore, for the Indian case to be higher than for the Brazilian case. So we see a deep reduction of 80% in the Indian case compared to 30% in the Brazilian scenario. And then I will use one example on the energy consumption to highlight some detailed element. So just on these energy efficiency gains, so here in megajoule per ton kilometer, these are, so that both countries is doing about a 50% reduction compared to 2010, because the starting year is different. I have started here in 2020, but the efficiency gains here reflects really different, a lot of different actions due to systemic transformation of the demand, of systemic model shift, or road vehicle shift, or vehicle and driving improvement, shift from ICE to EV, or average load factor improvement. So I will not enter into all the different details, but behind these numbers are all these different elements. I would just highlight one of them related to the systemic transformation of the demand, just to show here, to cross the information of spatial dimension and modal shift. So we can see here between Brazil and India. So Brazil have made a distinction between the traffic that is below 50 kilometer trips and above, and India below 150 kilometers and above. And we can see that more or less for both countries, even if the limit is a bit different, we see that the share of road transport will still remain dominant in the short distance travel, but is reduced a bit in the case of India. And in both scenarios, in both countries, for the distance that are above the 50 kilometer or 150 kilometer limit, they see that the share of road transport could be reduced and to favor, so I mean in favor of rail and water. And the reduction of the road share is about 15% over the period 2020-2050. Now I see that the time is running, so I will stop here. I had other slides that I will not develop, and I will just open for a round of questions. I have listed some challenges, and thank you.